They reveal that humans have always been fascinated by patterns in number and the hidden relationships within geometry. Archimedes and the first mathematical breakthrough. One of the most significant breakthroughs in the history of pi actually came from the Greek mathematician Archimedes around 250 BC. Archimedes devised a brilliant geometric method as an approximate of pi. He actually inscribed and circumscribed polygons around a circle and calculated their perimeters by increasing the number of sides of these polygons. He was able to narrow the possible value of pi. Using polygons with up to 96 sides, Archimedes showed that pi lies between 3.1408 and 3.1429. The method was remarkably sophisticated for its time and laid the foundation for future mathematical discourse or discoveries. Archimedes' work demonstrates the power of logical reasoning and mathematical complexity and creativity. Global contributions to the study of pi. The exploration of pi did not stop with the Greeks. Scholars from many cultures contributed to its study. In China, mathematician Zhu Chongzhang calculated pi with remarkable accuracy during the 5th century, and his fraction was 355 or divided by 113, approximately pi correctly to 6 decimal places. During the Islamic Golden Age, mathematicians such as Akashi extended the calculation of pi to several more decimal places through remind us that mathematics is truly a global human endeavor shaped by contributions from diverse cultures across centuries. Let me zoom into the birth of the symbol pi. Interestingly, the symbol pi itself was introduced much later. In 1706, the world's mathematician William Jones used the Greek letter pi as a symbol to represent the ratio of a circle's circumference to its diameter. Later, the renowned mathematician Leonard Euler popularized the symbol in the 18th century, and it has since become one of the most recognizable symbols in mathematics. Pi in modern mathematics and science. With the development of calculus in the 17th century, mathematicians discovered new ways to calculate pi using infinite series and analytical formulas. Today, powerful computers have calculated trillions of digits of pi. While such precision is not necessary for most practical applications, these calculations help test advanced algorithms and computational methods. More importantly, pi appears in many areas of science and technology. In geometry, pi appears in formulas for the circumference and area of a circle. In physics, pi appears in equations describing waves, electromagnetism, and even quantum mechanics. In engineering, pi is used in designing machines, turbines, and circular structures. In statistics, pi appears in the formula for the normal distribution, one of the most widely used probability models. In computer science, pi plays a role in algorithms, simulations, and numerical analysis. Thus, pi connects mathematics to science, engineering, technology, and data science. But what exactly is the beauty of math? And how beautiful is mathematics itself? Beyond its practical applications, pi represents something deeper. The beauty and elegance of mathematics. Mathematics often reveals profound truth through simple ideas. From the geometry of circle emerges an infinite number whose digits continue forever. Mathematics is not merely about numbers or formulas. It is about patterns, reasoning, creativity, discovery, and problem solving. Many mathematicians describe their work as a form of art, just as artists create paintings and musicians compose melodies. Mathematicians construct elegant proofs and uncover hidden structures within numbers. Pi, with its endless digits, symbolizes the infinite length of mathematical knowledge. Mathematics and the future. As we celebrate Pi Day today, we must also reflect on the critical role mathematics plays in shaping the future. Fields such as artificial intelligence, data science, cybersecurity, robotics, climate modeling, digital communication, all actually rely heavily on mathematical thinking. For Ghana and many other nations, strengthening mathematics education is essential for technological advancement, economic growth, and national development. Countries that invest in mathematics education are better positioned to innovate, solve complex challenges, and compete in the global knowledge economy. I have a message for you, students. And the message is for you to actually make sure that let's us encourage, and I want to encourage you to embrace mathematics with confidence and curiosity. Mathematics is not a subject to fear, as most of you think. It is a powerful tool that helps us understand the world and solve real problems. Every mathematical challenge you actually overcome strengthens your ability to think logically, analyze situations, and develop creative solutions. Who knows? The next major mathematical discovery may come from one of you sitting here today. And to us educators, to my fellow educators and stakeholders in education, today also reminds us of our responsibility. We must move beyond teaching mathematics as mere memorization of formulas. Instead, we must teach mathematics as a way of thinking, a way of reasoning, questioning, and exploring. Let us create classrooms where students feel inspired to ask questions, not to be engulfed with fear, investigate ideas, and appreciate the beauty of mathematics. When we teach mathematics well, we are not only preparing students for examination, we are preparing them to become problem solvers, innovators, and leaders. To bring my submission to a close, as we celebrate World Pi Day today, let us remember that pi represents more than a number. It represents the endless pursuit of knowledge, the power of human creativity and curiosity, and the beauty of mathematical discovery. From ancient civilizations to modern supercomputers, pi has accompanied humanity on an extraordinary journey of exploration. May today's celebration inspire all of us, students, educators, stakeholders, and members of our wider community to continue exploring the fascinating world of mathematics. Let Pi remind us that within even the simplest ideas lie infinite possibilities. Happy World Pi Day and happy International Mathematics Day to you all. Thank you very much.
Let's keep clapping to his. Thank you, Dr. Yakwa, for this insightful and the significance of Pi Day. I believe we've learned a lot. Before we proceed, we would like to introduce one or two dignitaries who just joined us. So the first on the list is Professor Douglas Dakon Ejei, Provost, College of Education Studies. Welcome, Prof. We have the Dean of the Faculty, Professor Iribi Atta. Prof, can you give us a wave? Yeah. This is the Dean for the Faculty of ICT, Science and ICT Education. And lastly, we have Professor Eric Wilmot, Department of Mathematics and ICT Education. Welcome. We also have some schools, secondary schools and basic schools joining us, and I would like to acknowledge them and the teachers. So the first on the list is University Practice SHS. If you are here, just give us a wave, led by Mr. Emmanuel Yeboah, the mathematics teacher. Then we have University Junior High School, South Campus. Let's see you. Thank you so much. We have Infantipim SHS, led by Mr. Abeka Williams. Can we see you? Thank you. We have St. Michael Catholic Girls. St. Michael Catholic Girls, Madam Sarah Isiwa. Thank you so much for honoring the invitation. Cape Coast Technical Institute. Cape Coast Technical Institute. Thank you. Led by Mr. Michael Apia. Then we have University Junior High School, North Campus. Efutu Secondary School. Efutu Secondary School. Let's see you. Thank you for coming. We have Ogwa Senior High Technical School. Ogwa Senior Technical School. You're welcome. And then lastly, we have Ghana National College. Ghana National College. Thank you so much. Mr. Chairman, ladies and gentlemen, to help us explore the infinite possibilities and guide us through the dynamic of mathematics teaching and learning in Ghana, please join me as we welcome Mr. Robin Todd, Executive Secretary of TTL, to give us the first keynote address. Let's give him a round of applause as he takes the podium. Thank you, sir.
You're welcome.
Thank you.
Thank you. So, Chair, distinguished professors, invited guests, all protocols observed. I have to say, when Dr. Yakwa invited me, I feel a bit nervous about this because I'm probably the worst qualified person to talk about mathematics education. I am an English teacher by background, not a mathematician. And I schooled in the UK. And in the UK, our education system is not as sensible as the system in Ghana. I'm serious. Or you look at it and you think, oh, all these things. In the UK, you do an exam at the age of 16, like your BEC, and then you can drop as many subjects as you want. Yes. So at the age of 16, I dropped mathematics. So it means all of you here in any of you in SHS2, SHS3, yeah? You know more mathematics than I do at school. Because I stopped at 16. And you only choose 3 subjects. I chose English, history, and geography. And I have to tell you, I regret that. And interestingly, the UK government regrets it as well. The UK government now are trying to make mathematics compulsory through until age of 18. But of course, some learners don't want to do that. If I look at my career and I look at my life, in my job now, mathematics is very important. It's critically important, understanding finance, budgets, those kind of things. But I've had to teach myself because I didn't have that grounding in school. Let's try a little experiment. Remember, I'm an English teacher. All of these gentlemen here are mathematics professors. Raise your hand if English is your favorite subject at school. Raise your hand if it's English. Okay. I'm seeing quite a few over here. Not so many over here. You can put your hand down. Raise your hand if mathematics is your favorite. Hey, wait a second. You were putting your hand up twice. You can't put your hand up twice. That's basic mathematics, Dr. Yarqua. They could only put it up once. Very good. It is great. It is really good that you like mathematics. Mathematics is so important to our everyday lives, as Dr. Yarqua was saying. Have any of you used AI? Any of you used ChatGPT or Claude or DeepSeek? The first time you use it, it seems like magic, doesn't it? I was on a course, and the first thing they taught us is AI is not magic, AI is mathematics. When you type into the AI, all that is a mathematical probability engine, which is computing billions of responses. So mathematics so complicated, so advanced, that it seems like magic. Mathematics is universal, and it is important to all of our lives. But we have issues with mathematics. I'm sure you saw last year the debate about the WASSCE results. 2025 WASSCE results in mathematics were much worse than English, social studies, or science. And it is a concern to all of us who work in education. With GES, we do an annual evaluation survey every year across senior high schools. We select SHS1 learners and we give them assessments in English, mathematics, science, and 21st century skills. Over the past 4 years, we have seen that the mathematics results are going down. The mathematics competencies. And this is in year 1 of SHS. Which means if we want to look at the issues with the WASSCE mathematics, we need to look back at junior high school and at basic schools as well. And I'm pleased to say that the Ministry of Education is taking this very seriously. They've commissioned an urgent research study, which is going to be taking place to try to understand what is it that is causing those issues in mathematics and what can be done to improve it. And I'm very pleased that Dr. Yarqua here has agreed to be an expert member of the panel. So your very own department here is going to be involved in overseeing that study. We've talked about the practical application of mathematics. And one of the issues that we've had, I think one of the reasons why some learners don't like mathematics is because you're just focusing on learning for the exam. Focusing on passing the BCE, focusing on passing the WASSCE, and then you're not really sure about how that knowledge will practically apply to the rest of your life. Well, the government has made quite a lot of changes. We've heard about the new senior high school curriculum that was introduced in 2024. The content is unchanged. Mathematics is universal. But what has changed is the focus on teaching, trying to make the teaching more practical, trying to ensure that you can apply that knowledge to real life. Exam question. You know, we have, is it the tan and cos and sine for the triangles? You can calculate the angle where the ladder needs to be against a wall by using that. A very practical application. On practical application and practical teaching. And teaching is really, really important. The examination system is changing. In 2027, learners will be writing a new type of WASI. When NACA looked at the WASI that we've been writing in the past, 90% of the questions are what we call depth of knowledge 1. NACA have used Webb's depth of knowledge when looking at the curriculum. Depth of knowledge level 1, DOK level 1, means recall and memorization. So 90% of questions in the WASI have been recall and memorization. Name, list. We've all seen those type of questions. The new WASI, which WIAC will be setting in 2027, only 30% of the questions are at DOK level 1. Only 30% of the questions are recall and memorization. 40% are level 2, the skills of conceptual understanding. Explain, describe. And 30% of the questions are at DOK level 3 and 4, extended critical thinking and problem solving. So the teaching has to change because the assessment is changing. And the assessment will see how you can apply mathematics to practical, everyday situations. One of the reasons why I'm so happy to support the UCC is that teaching plays an enormous role in whether learners understand mathematics and like mathematics or they don't. One of our subscribers, one of our founding members of TITA, Perpetual Wajoli, she is currently at UEW. She's doing a master's degree. When she was in primary school, mathematics was her favorite subject. When she was in junior high school, mathematics was her favorite subject. But then she went to senior high school, and suddenly she found that mathematics was very difficult. She was asking the teacher to explain the concepts. The teacher said she should just read. She shouldn't be asking questions. And so she ended up failing mathematics at SHS level. And then she went to a college of education. She went to St. Teresa's College of Education in Hohoi. And they had a special initiative to make science and mathematics education more practical. And she suddenly found that she was scoring top of her class again in mathematics. And she graduated from St. Teresa's with a first class qualification, the highest in all of the college. So then the question is Perpetual good at mathematics or bad at mathematics? She's good at mathematics, isn't she? But she found it difficult in senior high school because the type of teaching was not supporting her to understand. And that's why I'm so happy to be here at UCC, because I know that this university is training teachers in the right way with the new BEd, so that when they go to senior high school, they'll be able to teach in a practical way. Final two things about the new curriculum. One, it is what we call a spiral curriculum. So it means that you touch a topic in year 1, then you'll touch the topic again in year 2, and again in year 3. which is a change, because sometimes in the past you do a topic in year 1, then you wouldn't touch it again until you have to write the exam, would you? And it's difficult to remember. And then the final thing that is new is that there is going to be, well, there's something called intervention mathematics, trying to strengthen the bridge between junior high school and senior high school, because sometimes that can be a big jump. So all the learners now, when they come into the senior high school, the school will deliver an assessment, and if they need additional support in mathematics, there are materials available to provide that support, and they will do timetabled intervention classes. So we hope that all of those things will help to improve the mathematics performance and help to drive Ghana forward. Finally, my daughter failed mathematics. I told you in the UK we sit the exam at age 16. She sat the exam at age 16 and she failed mathematics. And I asked the school, can she resit the exam? And the school said, oh, she's not good at mathematics. No, there's no point in spending your money getting her to resit. She's not going to be able to. But I spent time with her. She's in the UK, I'm in Ghana. 3 times a week, we would do an hour Zoom on the mathematics. And I was learning at the same time. I was learning and I was teaching her. I was learning, I was teaching her. And she passed mathematics. And she got a place at university to do sociology and criminology. And after the first year, it was a BA, she realized that she liked the mathematics so much that she changed to the BSc quantitative methods. And now she's doing research and statistics, and yesterday she secured her first graduate job. And mathematics is a part of that job. So my advice to you, don't listen. If people tell you, oh, you can't do this, you're not good at it, don't listen. Believe in yourself and take time to understand what it is that you're learning. And it's never too late to gain that love of mathematics, because mathematics is something that will help you in your life and your career in future. So thank you very much for listening to me. Thank you.
Thank you. Thank you. Mr. Chairman, students, teachers, and our eminent guests, it is clear that when we apply mathematical lens, we do really unlock infinite possibilities. Thank you, Mr. Todd, for showing us the dynamic of teaching mathematics and learning in Ghana. God bless you. At this juncture, we know now that mathematics isn't just found in equations. It is also found in our language and arts. So we'd like to treat all of us with Pi poem recitals. I'll call upon Agnes Efrifa Asante, Sheila Mauk Kosa, Abigail Dede Sowa, Comfort Esinam Amuzu, and Priska Ifa to give us the Pi Day recitals. Shall we give it to them as they are coming to the stage? A round of applause. A round of applause. Please, let's keep clapping till they get to the stage. Let's keep clapping. Thank you.
Good morning, ladies and gentlemen. Please, we are here to recite a poem on the pie. the mystery, the magic and beauty of pie. So the mystery. Okay. So the mystery of pie. A circle turns in quiet grace. No beginning, no end, no stopping point. A number lingers. A number lingers, bored inside its curves. A magic code we called pi. The story starts with 3.14, but endless digits never end. Thank you.
The magic of pi. Pi is a number, steady and wise, found in circles in every size. 3.142 begins its story. It begins and continues forever long. A tiny symbol, yet vast and strong. This is a simple magic of pi. Thank you.
The beauty of pi. Pi connects all circles. It is mysterious and endless. It never stops and it never ends. It finds its beauty ways to connect all circles. It follows all trends in mass. Thank you.
Distinguished guests, ladies and gentlemen, I greet you all. In our textbooks, pi is represented by a relatively small value, sometimes 3.142, other times 22 on 7. But the value of pi is such that its decimal sequence goes on and on without repetition. This characteristic feature of pi allows us to find all sorts of combinations in its pattern. It could be your date of birth, your phone number, your Momo pin, or even the date of the day you had your first kiss. Yeah, I know, right? With this, I'll share a poem titled Endless Surprise. A value that never ends, pi. It goes on and on. Just why? Please, allow me to enlighten you. It might just change your view. Pi is the ratio of a circle's circumference to its diameter. It can be found in the Greek alphabet like theta. Pi is irrational. It is not the root of any non-zero polynomial equation. Hence, we say it is transcendental. Pi cannot be written as a simple fraction. It has a non-repeating pattern. Its symbol was introduced by William Jones in 1706. Egyptians estimated its value to be 3.16. Pi Day was founded in 1988 by Larry Shaw. The essence to celebrate this day, he saw. Enough with the history. Looking at its uses, it is the backbone of circular geometry. It appears in the laws that describe oscillation. It is the basis of wave motion. An endless surprise wrapped in the logic of a perfect circle. A puzzle we are ever ready to tackle. All these I'm saying are facts, not even a single lie. Let me guess, at the moment you are craving a piece of pie. Thank you.
I believe we can do more. Please don't go. Please come. There's something special I'm going to say about you. Especially the first 3 students. They are our pioneers in our new program, Beard, Robotics, and Artificial Intelligence, and Intelligence Systems. So, we are proud of you. Thank you. You can go and sit down. Yep. Oh.
We are also very grateful for your sweet poem. Well done.
Mr. Chairman, we've now come to the heart of our today's celebration. In a world of uncertainty, mathematics is often seen as a cold science of logic. But today, we explore it as a beacon of hope. To guide us through this powerful theme, we are privileged to have our main keynote speaker, Professor Douglas Dakon Eje, the Provost of College of Education, University of Cape Coast. Shall we give a round of applause as he mounts the stage? Thank you, sir.
Thank you. Let me also observe the protocols already established. Good morning. Good morning. I hope you are all fine this morning. Can I say I wish you a happy Pi Day? And how will you respond? Same to you. We need to find a response. Same pie. So, a happy Pi Day. I didn't hear you. A happy Pi Day. Good. I was asking somebody why you think, I don't know whether Dr. Yakwa might have said that I came here a little late. I'm quite sorry about that. But I was asking somebody why we think that the Pi Day is celebrated today. What's today's date? 14th March. And so, do you know why it's being celebrated today and not yesterday or tomorrow? Yes. Who can tell me? I want the children. I can see a hand there. Yes. The guy, no, you don't look back. Anybody from that place? Okay, get up and say it. Today is Saturday. Aha. Yes. Any other reason? That is reason. Yes. Okay, so she's also saying that's her reason. The other one is also correct. Today is today not Saturday. And then somebody is also saying that because of the first three significant figures, that's 3.14, and that's also correct. I'm sure if you also had your answer, it's correct, but keep it for now. So, it's very, very important to know that the first three significant figures, and I am so much impressed. I don't know what to add. You have done my keynote address for me already. So I heard Dr. Yakwa talk about all the issues, and I heard the poem. But I'll just do something because you want me to be here. So it's true, 3.14. Of course, if you take your calculator now or your phone and you divide 22 by 7, you are going to see it begins with 3.14, and then it continues and it continues and it continues. So 314, if you are coming from the back, is what? 14th March. Depends on how you write your date. Some will want to write the day first. Some also want to write the month first. So if we have 14th March, we are writing the date, the day. The date, that's out of the 30 days or 31 days, 14th March. And this is celebrated in the whole world, as we have already heard. And the interesting thing about it all, those who recited the poem have talked about it. The fact that it is unending, and the fact that it's indefinite, then the fact that it is not repeating. What again did we hear? So we are talking about endless possibility. And I think that's a very important thing we need to take home today. That the pie teaches us about endless possibilities. What does it mean? It does not end. There's no repetition. So I think there are three important things we need to understand. The fact that, or it reflects that growth itself has no limit. Growth itself has no limit. It also shows that learning has no boundary. So if you are here and you are in primary 1 and you saw the Director General, Ghana Education Service, and we read his profile, and then you heard all the beautiful things about him. He started somewhere where you are now, or even earlier, right? Learning has no boundary, and he continued learning and learning and learning. Maybe there are some of you here who could even learn and bypass wherever he ended and go beyond that. That's one of the significance of the Pi Day, that learning has no boundary. So you can choose to learn and learn and learn, and there's no boundary to it. Every student can go further than he or she can imagine. I don't know what your vision is, especially the kids here. I don't know what you want to become. But today, we are being reminded by this occasion, which we are calling the Pi Day, that what you have even thought of becoming, you can go further than that today. Because the pi is indefinite. The pi does not end. It's not repeating. It's irrational. So wherever you find yourself, you should have this feeling that you can go beyond what you can or what you have imagined. In this case, we all want to agree that pi is a perfect symbol of hope. So I am happy we are talking about mathematics and hope. Pi itself is a perfect symbol of hope. It stands for hope. But it's not just only pi, because we have seen that it's a constant. It's something that is in mathematics. So just as it's a perfect of hope, we also want to understand that mathematics is a tool for hope. And so that's the little bit I just want to talk just a little bit about it, and then I will end it. What do we mean when we say mathematics and hope? It means it serves as a language of hope. So I heard Robin talk about mathematics being a universal language, right? Which is true. And then Dr. Yako also talked about it. And I am adding that it's also a language of hope. That is why even when we look at our curriculum, whether the old or the new, mathematics is a subject that is a necessity before you can carry on from one level to another. You need to have passed the subject of mathematics. I will share some experiences that I'm sure some of you have heard. So, in our everyday life, mathematics provides hope by empowering and shaping what we do or our lives. So, under the theme, that's the first thing. I don't know how many of you have heard of this story about some young people who use mathematics to solve, I think, a group of junior high school students in the Eastern region who designed a solar-powered hand-washing machine during the pandemic. I don't know how many of you heard about them. Here in Ghana, I'm not talking about UK or London, I'm talking about here. And so that's one of the things that some people like us here were able to do with the knowledge and skill they applied from their mathematics lessons. So when we are talking about mathematics as a hope, or a language of hope, or mathematics and hope, one of the things we need to bear in mind, it has the ability to provide young learners like us the skill to be able to be innovative, even to achieve our aspirations in life. That's one of the things that we need to know. These ones use concept in ratios. These kids, they use concept in ratios, logical reasoning, measurement. I'm sure you've done some of these topics, and they were able to design this hand machine program that was powered by solar to do what they were able to do. And it tells us that when young minds use mathematics creatively, hope itself can become visible. I don't know what your hope is, but that's one of the lessons, or that's one of the main things of the team I want you to, when talking about mathematics of hope, we are encouraged, whatever you have done or know in mathematics, if you use it creatively, you are able to translate your hope to become visible. Another aspect of the team is about the use of mathematics in our everyday life. It doesn't matter whether you are in school or out of school. So I will also tell you about this story, which is also a true story about a cocoa farmer. Again, I don't know whether you have heard this, also in Ghana. This cocoa farmer visited his farm and he saw the pods or the fruits. I mean, it was recurring. Then he wanted to find out why it is like that. So maybe he had done some junior high school mathematics or maybe senior high school mathematics. But we are told that one of the first things he started doing is he started counting the pods, picking them, counting them, and then trying to track rainfalls in the area. Then later, he went into the calculation of averages. And then later, he went into some simple graphs, trying to see how, or the trend, the pattern. As we heard, mathematics is also about patterns. Eventually or gradually, he was able to track the problem of the issue. And that has got to do with the pruning he does, the times he used in doing it, the scheduling about the pruning. And that's how he was also able to solve his problem. And again, we see the power of mathematics. I'm saying all this because you see, like Robin said, some of us may not carry mathematics to the university level like the professors we see here, and then maybe go into dive into research in mathematics. But you might have done some core mathematics, for example, maybe up to the junior high school, senior high school. There is power in it. You can use it in your everyday life. Our mothers and grandmothers who never stayed in the classroom, myself to get to my tomatoes on the market. So these are everyday use of mathematics, and I think that's one of the things we need to take note of. I know of a story also of a young man who graduated from the University of Cape Coast, did some mathematics, and he joined an institution in the US and did engineering. I don't know how many of you have heard about that. And then he joined the National Aeronautics and Space Administration, NASA. And he was given a specific task because part of their mission was to explore Mars. And he was a renowned person. His name was all over. And if you track his background, it is to the University of Cape Coast. And you check the subject he was doing what? Mathematics. In fact, he specialized, we are told, in the area of geometry and motion equations. And that's how come, after diving deep into this area, he was able to join NASA, and then was able to join the team to explore so many issues within maths. So what does it tell us? Mathematics connected to him is a way of, or is a way of telling us that the little bits we are doing here, whether in the primary school, whether in the senior high school, whether in the university, has some implications or has some usefulness which we can also explore in our lives. Utilitarian value of mathematics, and I'm sure Dr. Yakwa talked a lot about that, so I wouldn't go so much into it. He's talking about the power of mathematics in other subjects, and that in the US, if you do mathematics in the secondary school, you can even dive into medicine. I don't think in Ghana we cannot do that. We could do that, but apparently maybe it has got to do with issues with constraint of resources. We don't have too many medical schools. So, of course, what we know is you should have done biology and then some other physics, chemistry, and other subjects. But of course, if you do mathematics, it can lead you to so many other disciplines. And I'll give my own case as an example. In the secondary school, I did everything. I did science, I did arts, I did business before I entered the university to read mathematics. How? I'll explain to you. We didn't do the senior high school curriculum. So those of you here, I'm sure most of you are thinking and talking about seniors, but we had the ordinary level and the advanced level. So ordinary level, you were supposed to do 5 years after elementary or primary. We used to call it primary. And then you enter the secondary school, do 5 years. First 3 years is a little bit generic. Then from the 4th and 5th year, you major in science, arts, or business, etc. So I was in science. So you can think of all the science subjects: physics, chemistry, biology, add maths. Then you add a few other subjects. I remember I added Greek, literature. Of course, English was compulsory. So I was in about 8 to 9 subjects. So after the examination in Form 5, ordinary level examination, you move to the advanced level. The advanced level, you either have to major in arts or science or business, depending on what you did at the ordinary level. I didn't do well in biology. My maths was okay. And before you be picked for sixth form science, you should have done so well in the sciences. My biology was weak, so it made my grade a little weak. Therefore, I was not going to be admitted into the science program, either to do maths, science, and then physics, chemistry, or biology, physics, chemistry. So, and I wanted to go back to my school. I was in Achimota school by then. Then they said the only way we can admit you is to change you from science to arts. Somebody who has a science background, the only art subject I had was Greek. So now I chose to add economics, which I'd never done before. So when I went to sixth form, I was now doing maths, economics, Greek. It was a weird combination at that time. But because of my maths background, I could easily move into economics. If you know how economics looks like. You see, if you are a very strong background in mathematics, you can easily do economics. So what people who have done 5 years and are going to add 2 years, I was going to just do it in 2 years. So that's how I became an art student. When I finished sixth form with my arts, I decided to also dive into business. I had to wait for 2 years at home because the universities were on strike. I wasn't sure of what I wanted to do in the university. Somehow at that point in time, I said, I want to do business. So I now went into business to do business management. I had done economics, but the economics grade was not too good. So I had to repeat it for the exams and mathematics and statistics. So before I could enter the university, I had science background, I had arts background, I had business background. And I think it's all because of what? The power of what? Mathematics. So when we talk about the utilitarian value of mathematics, that's what we mean. The ability to dive or move to other areas is possible with mathematics. So that's another thing that as we think of mathematics and hope, it has that implication for us as students, as teachers, and the hope that mathematics brings us, even as far as our subject combination is concerned. Maybe without the mathematics and having failed in science, I will not be standing here. That became my hope. And somehow I was able to continue now standing before you as a mathematics education professor. And so I look back and I realize that all the subjects I had engaged in, somewhere along the line, I drop, and then the only thing that keeps me or that brought me this far is the mathematics. Having gone into science, having gone into arts, having gone into business, I said, well, at the end of the day, it looks like I need to narrow as I go up, and that's the power of what? Mathematics. And I think that is something we all need to appreciate. Generally, mathematics provide us with hope in life. You see, when you do mathematics, one of the things, like we said, it seems to be abstract. That's how we've seen mathematics because of the way it has been taught. And I'm not surprised Roman said he dropped it. Because if you talk to so many people who are not math background, if you ask them what's a subject that is very difficult for you, the first thing they will mention is what? Mathematics. And when you're asking them why, they will tell you it's complex, it's abstract. So any person that goes through mathematics or does mathematics or teaches mathematics, you are able to acquire some kind of develop. Every mathematical problem teaches lesson beyond the classroom. One of them is complex problems that teaches us patience. Hello? If mathematics is complex and you have to struggle and solve a problem, one of the skills is developing in you is what? Patience. And if you have patience, you have hope in life. Wrong answers. How many of us have solved mathematics and the answers were wrong before? Good. Yes. Did you try again? Some of you didn't try again. How many of you tried again? And when you try again, did you get it right? So there's no and yes. Those of you who said no, did you try again after getting it wrong? Okay. So one other thing that is developing us is resilience. Resilience. Another thing is it teaches us to be determined. When I failed, in fact, I didn't tell the whole story. Even though maths kept me through, my maths grade was even still weak. Because the A level, if you get a grade in D in maths, it's not bad. Even if you get E, you can still proceed with it. I won't tell you what I had. I will not tell you what I had. But my grade wasn't good. But I was determined. So when I shifted to business, again I did a level mathematics. The grade I had in the first attempt was the same grade I had in the second attempt. And when I shifted to business, I repeated the A-level mathematics again. It was the same grade. Determination is one of the things that we learn when we go through mathematics. And the last thing we learn is what? Confidence. So I want all of us here to develop these characters. Because if you can have any hope in life to continue, these things are key. resilience, determination, patience, and confidence. These are very important. There's no problem that is too big. There's always a way through. This mindset is the foundation of hope. And this mindset originates from either teaching or learning mathematics. I want to be closing, and I want to leave these closing remarks. I didn't want to touch on the professional areas because Dr. Yakwa talked the career areas because Dr. Yakwa talked a lot about it. How we use maths and artificial intelligence, cyber security, medicine and public health, climate science, etc. But if mathematics is important in this way, and we see it as a language of hope, as far as our careers are concerned, as far as paths that we have to go through can be diversified, just as in my case, then what is the implication for us? The students here, I want to admonish you to take your maths lessons seriously. That is not to say that the other subjects don't take it serious. No. You equally have to take your other subjects serious. But you also must be mindful of the subject mathematics, having in mind its usefulness and its utilitarian value. You need to take your maths lessons serious. Teachers who teach mathematics are teaching methods very, very important. If these are the possibilities, infinite possibilities of the subject, then we need to be mindful that in teaching it, we are careful not to discourage students from doing the subject. Because a number of times, if students will develop the habit or develop the interest in mathematics, it does not begin at the university. Sometimes even at the elementary school. So teachers, we need to be mindful of that. Be real models and encourage our students. And then finally to the department and all other teacher education institutions which are responsible for preparing mathematics teachers. I think we also have a huge responsibility because whether the teachers will perform, which will cascade to students' learning, it depends on our work as teacher preparatory institutions, whether we are doing a good work or not. And we need to be mindful of that, so that in preparing teachers, we do the needful and ensure that teachers are well prepared for our society. Today, as we celebrate Pi Day, let's remember that mathematics is not just a subject to be studied, it is a tool, a mindset, and most importantly, a source of hope. The hope that a child in primary school may become a world-class engineer. The hope that a junior high student may design the next national innovation. The hope that senior high school students may solve problems that uplift the communities in which they are coming from. The hope that a university student may create technology that transforms the world. Mathematics lights the path to a brighter future for Ghana, for Africa, and for humanity. Thank you, and happy Pi Day.
I believe we can do it better. Wow. Wow. Thank you so much, Professor Douglas Ejay. At the beginning of the program, I asked a question that can mathematics give us hope? And if I come down to ask this question individually, I believe you can give me answers now. Prof has shown us that mathematics is not just a subject in the textbook, but a language of hope and a tool for building a better world. He also, said that it teaches us certain skills. At least he has given us 4. And I believe that we will go home and then reflect on this, what mathematics can. So, Prof. Didi, thank you so much, and we are deeply grateful for those insights. God bless you. I'll hand over the microphone to my co-MC, Dr. Benin. But we have snacks for all of us. So, very soon, the protocol team will come around with our snacks. Whilst we are enjoying the Pi Day snack, we also enjoy the next activity, which is Pi Rap. They are coming to rap to us. I don't know what that rap means. So let's sit and relax the snack whilst we enjoy the Pi Rap. Dr. Benin.
Thank you. So, how many of us joined us this morning for the float? All right. I think when we got here and we had a media engagement, the students were asking us, what is the slogan for the ceremony? Actually, we had not thought of it, but I have to think on my feet and say, okay, when I say mathematics, respond hope. And that became our slogan for this International Day. So when I say mathematics, what are we going to say? Mathematics. 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 And the provost of the College of Education has taken us through what we have when we have mathematics. And what we have when we have mathematics is hope, because it prepares us for the future generation. There are some acknowledgements and also there are some acknowledgements we have to do here in terms of our sponsorships. In the first place, we need to acknowledge the genesis of this celebration, or who originated it for us to celebrate it today on the UCC campus auditorium 900. So the idea came from our HOD, Dr. Christopher Yakwa, during, where is he? So that we give him a big clap. Yeah, HOD, please. Yeah. So we are all gathered here based on his idea. And we are also acknowledging the management of the university. Because when you moot an idea, you need to get a support. Other than that, his idea couldn't have been materialized. And we thank our dean, Professor Kofi Aibiata, for accepting it. Because from the department level, it has to go to the next level. From the next level, it has to go to the college. And our provost, Professor Douglas Dakun Eje, also saw the significance of this great activity. It didn't end at his level. It has to go to the top, to the VC, to approve it. So we thank all these levels of management for making this occasion possible. Now, when they approve the program, of course, as we are here, we have some bottle of water. Very soon, we shall have our snack, which we will eat pie and drink pie. It is possible that there are some people behind it, and these are our sponsors. We had support from TTEL, that's the Transformation Teacher Education and Learning, Robin Todd. Thank you and your institution for supporting us. We also had a support from the College of Distance Education. It's just here. They also supported us. Apart from this, there are individual support. Our own students, MPhil students, PhD students, then the undergrad students, they also supported us through Momo. We also have Mr. Bonnie, I believe. Okay. We also had Mr. Bonnie. He provided us with water. Then Vivian Nimo also provided us with water. Mr. Apietu also supported us. No, when I don't have my glasses, it becomes so difficult. Okay. I don't want to mispronounce the name. Okay. So we have Na Dina Donglaboni. I believe I've gotten the name correct. That's why I said I needed the glasses. Otherwise, I was struggling. Even with the glasses, I'm still struggling. So it's Ghana the third. He also supported us. Then Dr. Nelly Abedu, he is a lecturer in our department, Department of Mathematics and ICT Education. Can we give them a hand of applause for all these individuals and the institutions making this occasion successful? At this point, though we have the program outline, but we are not going to follow it linearly. We need to make adjustments so that we can finish on time. What we want to do is that we are going to have a pie wrap. So there are some people who have rehearsed, music. So we are going to see how math is in music, and also music is in maths. When that is done, we shall have our esteemed professor in math education, and currently he is the Director General, Ghana Education Service. He's a mathematics educator. So after the wrap, Prof will come and also give his talk. Just after his talk, the snack break will be going round. We shall not go out. So the snack break, we will have it here. So after Prof talk, and whilst we are enjoying the snack break, we will set the place for our quiz competition. And we will really know those who have much information about pie. So at this point, shall we invite our pie wrappers Victor Chikata, Deborah Adai, Lisa Forsen, Emmanuel Akomia, and Fiona Talley. Did I get the name correct? Fiona Talley. Shall we give them a hand of applause whilst they give us an interlude by rapping Pie? Okay, so we can. Can you please get another mic? You have this one.
Good afternoon. I'm Victor Chikata. I'm here with my colleague,
Deborah Day.
We have just arrived from the United Kingdom of Pi, and we are here to entertain you with a 2-minute rap. When you hear Pi, we are referring to mathematics, chemistry, any skills or any subject that require your arithmetic skills. Kindly tap go and enjoy our rap. Our reading is taken from the Holy Book of Pi, chapter 22/7, verse 3.14159. Are you ready for the pie?
Ready for the pie.
When I say don't hate the pie, say love the pie. Don't hate the pie.
Love the pie.
Don't hate the pie.
Love the pie.
Are you ready for the pie?
Ready for the pie.
Pie, pie, pie. Don't fear the pie.
Learn the pie.
You are learning the pie.
It's making you confused.
Eat a pie.
And learn the pie.
You are learning the pie.
And your head want a pie?
Call your peers.
To teach you the pie.
They teach you the pie.
Don't pile up the pie.
You pile up the pie.
Your head go pie.
Eat a pear.
And try the pie.
Don't fear the pie.
Learn the pie.
You fear the pie.
Your hair will glow.
Be friend with pie.
Have your pea.
Learn the pie.
And have your peas.
Don't fear the pie.
Learn the pie.
Don't fear the pie.
Oh, learn the pie.
Don't hate the pie.
Just learn the pie.
Don't hate the pie. Just
Love
love the pie.
All right. My name is Emmanuel Akomia, and I'm here to give a song about pie. All right, so here we go. A long, long time ago, I can still remember how my math class used to make me snow. Because every number we will meet will terminate or just repeat. But maybe there were numbers that did more. But then my teacher said, I dare you to try to find the circle's area. Despite my every action, I couldn't find a fraction. I still remember if I try, the more I cry, circumscribe. There's something touch me deep inside. Till the day I learn of pi. Oh, pi, pi, mathematical pi. Twice 11/7 is a mighty fine try. A good old fraction you may hope to survive, but the decimal expansion won't die. Decimal expansion won't die. Pi, pi, mathematical pi. 3.1415926535893 say a good old fraction you may hope to survive, but the decimal expansion won't die. Decimal expansion won't die. Pi 3.14159265358979328340622974502 pi mathematical pi. Twice 11 over 7 is 75 try. A good old fraction you may hope to survive, but the decimal expansion won't die. Decimal expansion won't die. Thank you.
Everybody, hi. I'm not a place or a time, a place of time, a time to combine or a signing code sign. I'm just pirate as an E. Hope you can see. Let me tell you a little more about me. Pi is a circumference over diameter. The 16 letter in the Greek alphabet. Mathematically 22 on 7. Same as 3.142. I remember the day like yesterday when I was first by William Jones in the year 1706 and celebrated by Larry Shaw in the year 1988. I'm not a pie you eat on your plate. No. Hope you can relate. I'm talking to you, Madam Kate. You will never stand next to me. I'll never be down by to my birthday, representing my first 3 digits, which is 3.14. Everybody about to do something. Pi in circle, pi in cone, pi in cylinder, pi in frosting, pi in sphere, pi in freezing, pi in pyramid. What's my name? Pi in circle, pi in cone, pi in cylinder, pi in frosting, pi in sphere, pi in freezing, pi in pyramid. What's my name? Hey, pi! Everybody, I come to do something. 1, 2, let's go. Pi, 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 pi. So, get up, everybody up. My ambition now, never die failing. So, I'm going to give you his right. Let me tell you something. Hey. I'm not a place or a time, a face or a line, a sign to combine or a tiny cosine, just a pride as an E. Hope you can see. Let me tell you a little more about me. Pi is the circumference over diameter is 16 letter in the Greek alphabet. Mathematically 22 on 7. Same as 3.142. I remember the day like yesterday when I was first by William Jones in the year 1706 and celebrated by Larry Shaw in the year 1988. I'm not a pie you eat on your plate. No, hope you can relate. I'm talking to you, Madam Kate. See, you never say an end to me. I'll never be without my birthday, representing my first 3 decades, which is 3.14. Everybody saying.
Hello. Oh, I'm not feeling the energy. Hello. When I say pi, you say day. Pi. Pi. When I say pi, you say day. Pi. Pi. Okay, so this is a small rap, and I hope you enjoy it. Okay. Yo. Let's talk about a number that will blow your mind. A decimal that runs forever. Ain't got no end inside. 3.1459 and then it just goes on. 100 trillion digits deep and still in down. Ancient Egyptians carried on papyrus back in the day. 1650 BCE they had it right. Okay. Archimedes drew his polygon. More side getting near. That same became calculus. Yeah, pi. That's pi. Pi is irrational and free. Never ends. Never is the key. You can take it. It goes everywhere. You think to know. Goes there, pi international and free. Never ends, never hurts, repeat.
Okay. Shall we give it to them? Wow. So we have featured Black Sheriff, Shatawale, Kofi Kinata, Stoneboy, Efia, and the rest. So the rhythm is math. Arrangement of the words is mathematics. Shall we give to them once more as they go and sit down? Thank you so much for such wonderful performance. I'm trying if I could remember one of the raps that they sang. It's all gone. Right. At this point, we are going to invite our Director General, Ghana Education Service, Professor Ernest K. Davis. Shall we welcome him with a big hand of applause?
He's fine.
Good afternoon, everyone. My friends there, I'm sure you cannot see. Kiptek, can you see? All right, thank you. And my bosses on the stage, you have to turn your head more than 180 degrees. Sorry about that. So, Chairman, Professor Chairman, permit me to proceed on the protocols that have been very well established to deliver my short address. My understanding is that I have to share my thoughts on pi in everyday life, and I have to do so in not more than 15 minutes. So it means that I have to be very snappy in my presentation. Let's see how it goes. I'll try to be obedient. I'll try to keep to my time. My name is Ernest Kofi Davis, and I'm the current Director General of Ghana Education Service. So I am the father of all the school children here. They are my children. But through the presentation, I might mention one school, don't worry. So this morning, I will take you through a brief introduction. My introduction will look like a repeat of what others have said, but I have written it already. I will look at mathematics in context, or the use of mathematics in everyday life. What theoretical support do we have for it? I will not go into deep theoretical discussion here. I will just touch the surface in ways that even my primary school children can understand. I will then give some few examples of pi in everyday, the use of pi in everyday life. And then I will add on to the implications for pedagogy and research, because we have some researchers here. Then I will exit the presentation with questions for the research community to go and think about it, and mathematics teachers. I must say my presentation is the easiest because all the previous presenters have said everything I have to say. So let's see the little I will add. So we have heard this morning that pi is key to learning geometry, trigonometry, and engineering mathematics. I heard in Professor Yako, Dr. Yakwa's presentation, my brother Provost's presentation. In fact, it helps students to understand the relationship between the circumference and the diameter of a circle. And this is fundamental in many scientific calculations. We heard that this morning as well. Because of its importance, school children all over the world celebrate Pi Day on 14th of March to promote interest in mathematics and science. That's why we have brought you here. So it's not happening only here, it's all over the world. So you are at the right place at the right time. I thought you would clap for yourself for coming. So you understand why we have to be here to celebrate this event. It has become an international event. Now, I want to look at mathematics in context and everyday life. What theoretical support do we have for it? You see, you can't separate life from mathematics. What will it take a dog or a cat to visit the place the owner feeds it every morning or every afternoon or every evening? What mathematical concept will get the dog to get it right or the cat to get it right? Concept of nobody want to tell me? Yes? Time. My primary school students have to. Concept of time. Concept of time. The dog must appreciate the concept of time to be able to get to where the owner feeds it every morning or every afternoon or every evening. Dogs are not human beings. They are animals, but they have mathematical sense. What does it take for animals to graze, go out grazing and come back home without losing or getting lost? What does it take them? Geometry. They should turn properly. If they don't turn properly and they turn wrongly, they will not get home. They will, So you see that I'm using animals before I come to human beings. So you see that you cannot separate mathematics from life. Mathematics, according to researchers such as Bishop and others, is a cultural object. And the literature suggests that every culture creates mathematics by engaging in some activities, 6 of them. And that is what they use to position mathematics as a plural subject rather than something that is singular. So the first they talk about, they are saying that everywhere human beings, whether primitive or present, are, they do these 6 universal activities. They count. Is that correct? They may not use the same language, the same words, but they may use things that gives them ways of accounting for things like tallying. They measure whether they have been to school or not. They measure. They use all sorts of measuring tools or tokens to try to measure. They locate. I told you how even animals locate where the grazing ground is. And the animals cannot, they don't have language, so they cannot say bearing of this degree or that. But they locate and they get there. They don't get lost. designing our Adinkra symbol, which colonial master gave them to us. Which colonial master? British? No. Designing. Then they play games, pastimes. Tomato, which colonial master gave us tomato game? Or you haven't heard tomato game? You can think about some of the traditional games in your, like Owari. Some of the traditional games you can think about. And then even the modern games. If you look at the rules that define the games, they are mathematical. Okay, the rules are mathematical. Then explaining, which I will use to argue about the need for us to pay attention to the use or application of power in the real life situation. Actually, the power of mathematics as a cultural object lay in its ability to explain things. Doing mathematics is good, where we manipulate the symbols, we try to solve to arrive at answers and so on and so forth. But explaining is what is linked to the utilitarian value of mathematics Professor DDAJ mentioned. What will it take you to tell me the next day we'll have Christmas? What will it take you? What does it take to tell me the next day, when Christmas will happen in 2 years' time? We can estimate easily, right? Let's see when it fell last year. We can estimate. Is that right? We know the calendar year. So we can estimate and even estimate the following year. And explain. That is the power of mathematics when we activate both the doing and the explaining. Now, pi in everyday life. Somebody should control my time for me before. So, as Professor DDAJ and previous speakers, Dr. Yakwa said, pi has many applications in everyday life. Engineering, architecture, my examples will be grounded more in the engineering and architecture, computer science, physics, and so on and so forth. Pi is essential in calculations involving circles, waves, as you heard, volume, and so on and so forth. Now, the crux of my presentation. Let's look at the pictures there. You can see the geometric shapes in the building. You see there are a lot of frozen mathematics in the building. If I can borrow Paulo's Gedet's words. A lot of frozen mathematics there. Look at the silver dome. What is the shape? Don't say circle. Yes. A sphere, maybe half of a sphere, isn't it? The dome, the top, the ash one. Look at the green one. And look at the beautiful edifice of a library. Look at the roof. Look at the building. I hope you can see from my school in Fansville. That's our library. in Fasting School Library. You haven't seen that. Look at the geometric shapes frozen there. How could the architect have developed this if pi had not been explored? How could they have done it to the level of precision that you see today? And the beauty, how could they have had it right? We'll see the contract soon. Let's permit me, I think I took too many pictures from one source. So look at the classroom blocks. This is in Fasting School classroom block. Pay attention to the building. You can see how variation in the radius affects the arcs that have been written, that have been drawn. So you can see the role of pi in architecture drawing. Let's look at the system that houses the water. How could the architect have had the exact number of gallons of water that could fill this system if some mathematical calculation had not gone on? Could they have done the mathematical calculation without pi? What shape do we see there? Look at the system. What is the shape? I want the result. The primary school, they are giving me a lot of answers, so I want the SHS. What is the shape of the system there? The system we saw. I'm looking at the top. What is the shape? Any attempt? Is it cylindrical? Yes, cylindrical. Haven't you learned the formula for calculating the volume of cylinder? Can you do that without pi? Can you imagine how difficult this would have been if somebody hadn't done that exploration? So, is it the case that people were not doing this already? People did it. You can see you can see that what I have projected also have some the cylindrical base. We have conical roof. Look at the gate. I took this picture from Sandema. Look at the gate. Can you see the gate? Can you see that it has a parabola shape if you take the cross section? Can you see that? Can you see a lot of geometrical shapes frozen there? Do you think those who were designing this had an idea about the shapes? They might not have had it, but they did the architectural design. They developed the product, which I'm sure was beautiful to them and is beautiful. They use pi, but they had no idea about pi. You get what I mean? They use it. Look, the fact that the dog will come at a particular time but cannot articulate time, does that mean the dog doesn't have an idea about time at all? So they also produce some product which has a lot of geometry, which you and I, who have studied pi, can understand that pi might have played a role in. They didn't know pi because pi wasn't an issue for them. You can also look at a lot of our artifacts. If market woman wants to do good business, you know that there should be calculation. The volume of each of the units of measures. How could she do a good business if she cannot calculate? And how can she calculate if she doesn't? How can she calculate effectively if she doesn't have pi, knowledge of pi? So, the crux of my argument. See what school knowledge of pi could do to the product to my right, so that will be to your left, and the one to my left, that is to your right. If pi had not been discovered, could you imagine how ugly many of the beautiful edifices would have been? You see that the picture to my right had precise measurement. The architectural designs were informed by precise measurement, calculation, mathematical calculation, driven by somebody's discovery. So the shapes you saw, these are the formula that drive them. For each of the shapes, you can see the formula. And you can see pi in each of them. You look at the cone, you look at the circle, and so on and so forth. You can see pi there. So what? They are copying. Oh. They gave me 15 minutes, so I will leave with them. Otherwise, you sleep here. I don't want you to sleep here. So, what? You see that pi represents humanity's long history of exploring and understanding the universe. Remember the sixth universal activity, explaining. Explaining in mathematics or mathematics education can be activated if we pay attention to relationships, if we explore mathematically. Because it took an exploration of the relationship between circumference and the diameter to arrive at this important mathematical discovery. So you look at civilizations such as ancient Egypt, ancient Greece, they studied pi while working on architecture, astronomy, and engineering. As I mentioned, it's a clear indication of active engagement with the sixth universal activity. Unfortunately, that is what we don't care about. That is what we don't care about at all. A student will work mathematical problem, teacher asks, why is it so? The student gets confused because once teacher has asked, it means something must be wrong. No, that is not what it is. In fact, as I said earlier, the power of mathematics as a cultural object lay in its ability to explain, and for that matter, its deployment in explaining our realities. If mathematical concept cannot be linked to context and reality, then it's not worth studying. Even in infinity, which we describe as abstract because you cannot see it, has its basis in reality. There is therefore the need for us to pay attention to mathematics as both doing and explaining. If you don't make sure that we balance the doing and explaining function of mathematics, we will destroy many mathematics learners. They can manipulate numbers, they can manipulate figures, but they cannot actually engage in any serious mathematical exploration, nor use mathematics to do anything. This calls for exploration of relationships, which was valued in certain cultural contexts, such as the European culture. You see, many of the mathematical discoveries came from Europe, Arabs, right? Algebra and co. Few of them came from Africa, even that not Africa. Why? Because their culture value explaining, which is core to quality mathematics teaching and learning. Valuing explaining through exploration of relationship between mathematical concepts is key to mathematical inventions such as pi. Assuming somebody didn't take the trouble to do that exploration, would we be here celebrating anything? No, wouldn't have been here. If you look at the syllabus, you see that we learn attributes of measurement such as length, we learn area, we learn volume, but how much of the syllabus asks us to look at, explore the relationship between these attributes? How much? How much? Is the emphasis on relationship, exploration of a relationship, that gives insight, that position our students as lifelong learners in mathematics. To bring my talk to a close, I will say that consciously inculcating the value of mathematical exploration will position Ghanaian students to acquire high-quality mathematical knowledge, skills, and values, as well as prepare them to contribute to mathematical inventions. The question I would like to pose to mathematics education community, because the community is here, as I bring my talk to a close, is how does the curriculum project mathematics as explaining, right from the foundational level to position students as lifelong learners in mathematics? If you want students to apply, it's not a matter of talk, apply, no. If you want students to be lifelong learners in mathematics, you need to inculcate in them values that will position them as such. And one of such values is explaining. Thank you.
Thank you so much, Prof. Davis. If you know Prof. Davis very well, he's deeply passionate about how mathematics lives in everything around us. He's an expert in ethno-mathematics, and he has taught us a lot. He was my supervisor. Prof. Davis, we are blessed to see you here today. Thank you so much. Please, we are still proceeding. We are continuing with our program. And to show us how to bridge the gap between abstract wonder and student mastery, we are privileged to have in our midst Professor Eric Wilmot to speak to us on the theme, Pi in mathematics education. Please, shall we give him a round of applause as he takes up the stage? Whilst we are also enjoying our pie and the drinks. Performance, are you coming up here? Okay. Thank you.
Good afternoon. I don't like holding mics, so I'm not sure how I'm going to handle this. If I put it down, will it still pick my voice? No. Okay, so we've heard a lot from our colleagues about pi and its importance. We're going to move a little bit into what pi is in mathematics education. So this is the presentation outline. I'll talk a little bit about the history of the origins of the idea of pi, talk about the conceptual meaning and derivation of it, and we'll talk about Archimedes' historical contribution about how to find pi. We will look at the geometric and calculus derivations of the area of a circle through which the idea of pi came, and we will do some inquiry-based teaching strategies. If it is in mathematics education, then I want to veer a little bit into some inquiry-based teaching strategies, and then the designing of some classroom learning experiences. At the end, I want to bring some assessment protocols involving pi. If it is mathematics education, we cannot just be talking. Assessment must creep in. So I'll end with that piece. Some historical considerations. Now, the first recorded algorithm for rigorously calculating the value of pi was a geometrical approach using polygons. And that was devised around 250 years before the birth of Christ by the Greek mathematician Archimedes. However, the first mathematician actually to discover pi was somebody called Thales. He was from Miletus. Miletus is present-day Turkey. So I will say he was Thales from Turkey. And it happened in 624 BC, years before Christ. So pi has a long history. Unfortunately, not much is said about Miletus, and not much is known about him. It is said that he was a merchant by trade and a mathematician by choice. Maybe that is why not much is written about him. He wasn't a cut-in academician. He was just a merchant. And because he was a merchant, he did rub his hands with the value of pi. Let's look at some conceptual derivation. So, conceptually, think about a circle like this. Think about drawing the diameter of the circle. If you have about 20 kids, let them draw the circle with different radii, and let them draw the, the diameter. If they can measure the circumference of the circle. And very soon I'll be showing you how, when all these things started, the circumference of the circle was measured. But if it can be measured, then the ratio of the circumference to the diameter, no matter the size of the circle, will give you a constant figure. And that constant figure, if you do it well, will be approximating any of the approximations of pi, 3.142, whatever. I mean, depending on the level of accuracy you give it, you will get it there. So pi then will be understood as the ratio of circumference to diameter. I remember when we were doing the undergraduate program, our time we did the diploma in education. And for the diploma in education, we had to do some project work. I remember going to the university senior high school here. That time it was university practice. It was called Unipra. And I got a number of cans, Milo cans, tomato cans of different sizes. And got the students to measure the circumference using a thread. So they will use a thread to go around the can, mark it, and be able to stretch it on a table and measure the circumference. And then they also used a protractor and a set square to now fix the diameter, measure the diameter, got them to find the ratio of the circumference to the diameter. And no matter the size of the circumference, we were getting something that was constant. And that value was always 3.14 something. So the fundamental mathematical constant that we know is pi. It is fundamental. It doesn't change. Now, students, if there are teachers here, I want to encourage you to aid your students to discover it experimentally. I mean, using one of the approaches that I'm going to describe, including what I just finished. Now, the approach that Archimedes used. This is one of the approaches. At the time, calculus had not been found. Isaac Newton and Leibniz had not brought the idea of derivatives. But this was Archimedes' way of thinking like somebody who wanted to do calculus. What was the concept? He showed that if one fills a circle with concentric, infinitely thin rings, think of it as onion rings. You see how the onion is? If you can rip it batch by batch, and then you cut it, once you straighten it out, you get something that looks like a rectangle. Now, if you cut it in various stages and you straighten them and you match all the tips at one end, you eventually get something that is like a right angle triangle. That right angle triangle, the height of that right angle triangle will be the same as the radius of the circle that you were cutting. And the base of that rectangle will be the circumference, as I said before. So from there, using the area of a triangle, half base times height. Remember, the base is the circumference, which we know as 2 pi, and then the radius is there. So half base times height will give us half times 2 pi times r, and then you get the r squared there. We can create several rectangles with a base equal to the circle's circumference and the height equal to the radius, and we can use that to explain this. I will show you very soon how, when then calculus came, they managed to move on further to use the idea of integration to still get the value of pi. So, still using the onion, imagine taking the area of the circle by summing up infinitely thin concentric rings like the onion I spoke about. If you look at those rings, the thickness will be the radius. Let's call it x. no, the radius will be x, and the small infinitesimal thickness, let's call it dx, is so small that we don't want to give it a value. If we cut this ring and lay it flat to become a rectangle, then we will have the length, as I said, being equal to the circumference of a circle, which will be 2 pi x. Remember, when it becomes a rectangle, we can now calculate the area of the rectangle. The thickness will be the dx. Now, if you sum this up from the zero thickness to the thickness that is equal to the radius, then you'll be finding an area which is actually the integral of 2 pi x dx. And if you sum this up from 0 to r, eventually you get the pi r squared. So all these approaches have been used in the past to get the area. Currently in the classroom, I wish there was a board here I can write. Currently in the classroom, what teachers do is that they can draw a circle and then divide the circle into pi pizza-like shapes. If you divide it as if you are dividing the pizza, and you get a lot of those pizza strips and start arranging them. So this is, let me see whether I have another handkerchief. Yes. So let's say this is one of them. The pizza is like this. The apex is here. The other one, if it is also like that, you lay it down in such a way that the apex will now come up and so on. If you lay it down like that, eventually the two halves of this thing will give you something like a rectangle. That rectangle, the length will be equal to actually half the circumference, because one half will be up and one half will be down. And then the breadth will be the radius. If you do that, then you see that the area of the rectangle that you are getting will now be 2 pi r, which is then the ratio that we want. So we can have pi being equal to circumference divided by denominator. And as the previous speakers have been saying, it's a number that doesn't end. It keeps going forward. It's not a recurring number. The numbers don't recur, but it continues going. 3.14159, so many things will come depending on the accuracy. However, the earliest written approximations are found in Babylon and Egypt. Do we know what the area that the Bible called Babylon is now currently? Babylon is the area where Israel is fighting the rebels. Not Syria. No, not Qatar. No, not Gaza. No, not Palestine. The area that is being controlled by the people who are fighting the Israelites. No, not Iran. No, not the Strip. Recently. The place Israel is bombing now. No, not Iran. The smaller one. Lebanon. Exactly. That is the geographical area that was called Babylon. So that was the area which first, in Babylon, a clay tablet that is supposed to be dated between 1900 BC and 1600 BC has a geometrical statement that by implication treats pi as 25 over 8. 25 over 8 is approximately equal to 3.125. In Egypt, the Rhind papyrus, which was copied and dated 1850 BC, has a formula for the area that treats pi as 16 over 9 squared. That value is also approximately 3.14. So you can see that in ancient Babylon and Egypt, the actual value of pi as we are dealing here was between their two figures, 3.125 and 3.16. The actual value, the 3.14, 159 that we are dealing with, is in between these two. So it is said that if you go to the pyramids in Gaza, there are measurements that are multiples of pi in there. There are measurements that are multiples of some of the irrational numbers we know. They are in there. So these people were actually dealing with some form of mathematics that have not been explained, by which people like Archimedes and co, through their work, got us to know some of the things that they want to find. This is also another, I think I have talked about this, cutting a circle into thin pie-shaped sectors and putting them together. When you do that, you get the area as pi r times r, so you get the area of the circle as pi r squared, and you can do that. So for classroom activity, I want to encourage, if you are a teacher here or preparing yourself to be a teacher, think about circular or cylindrical shapes of varying sizes, whose circumference you can measure and whose diameter you can measure. Make your students take these measurements, calculate the ratio, after finding a measurement of the diameter, and you'll be surprised to see that the ratio will always come to pi. Students can investigate the circles, collect data, analyze results, and then see. Assessment strategies with pi in mind. I'm going to look at 4 types of assessment questions that can be asked. The first one I'm going to call conceptual questions, and I think each of these I've tried to put up about 5 questions. The second one is application questions. The third one is derivation question. And then the last one will come to your real world application questions. So let me take them one by one. The assessment strategy 1, sample conceptual questions. I've just put these questions there. It's not meant to be solved. Explain in your own words what pi represents. You can ask that question in class. A student says pi is equal to 3.14 exactly. Explain whether this statement is correct or incorrect. So these are all assessment questions you can use in class. And by asking these questions and getting them to explain the idea, you will see if they have a conceptual understanding of pi, it will come out. If you measure the circumference and the diameter of 2 different circles, would the value of C over D be different or the same? Explain why. Number 4, why does pi appear in formulas for both circumference and area of a circle? And then 5, is pi a rational or irrational number? Explain what this means. These are the type of questions that you can ask to assess students' conceptual understanding. If we want to get them to apply, we can ask questions of this type. It will show you the procedural competence and the correct applications that they can. Find the circumference of a circle with radius 7. That should be easier, 7 centimeters. Find the area of a circle with diameter 10 centimeters. 3. A circular field has radius 14 meters. Find the area of the field. And then 4. Find the radius of a circle whose circumference is 44 centimeters. And find the volume of a cylinder whose radius is 3 centimeters and the height is 10 centimeters. Assessment strategy 3, the derivation type of questions. These assess deep mathematical understanding. That is, understanding where the formula comes from. Number 1, explain why the circumference of a circle is given by C equals pi d. Explain. You want them to show evidence that they know where this formula comes from. Explain conceptually how rearranging circular sectors lead to the formula A equals pi r squared. 3. Explain why doubling the radius doubles the circumference but quadruples the area. So if you double the radius of a circle, it will double the circumference. But in terms of area, it will quadruple the area. Explain why. And if students actually understand these formulas, they should be able to explain. Number 4, explain why pi appears when calculating the area using integration of circular rings. And explain why pi is constant regardless of the size of the circle. 4, some rare world questions. Professor Davis has touched on some of them. These are the type of questions that can assess the ability to apply mathematics to real situations or authentic contests. A car tire has a diameter 0.6 meters. How far does the car move after one full rotation of the tire? A circular water tank has radius 2 meters and height 3 meters. Find the volume of water the tank can hold. A circular running track has radius 50 meters. How far does an athlete run after one lap? We go into this sports program almost every year. This will be an interesting question you can ask even the JHS students or the SHS students. So you are running this track. If they want to cut a new track, let them be able to explain some of these things. A circular pizza has diameter 30 centimeters. Find the area of the pizza. And a farmer wants to fence a circular region with radius 10 meters. How much fencing material does he need? You can even ask tiling. How much tiling material can he need to tile an area? When it is fencing, you know the concept you are playing with is the circumference. This one is optional. And because I heard that you were coming, I thought of this just this morning. I said, oh, let me give something that teacher trainees can also think about and benefit. And I give a number of questions, about 5 of them like that. Question 1, design an activity that allows students to discover pi experimentally. They should be able to ask these questions in their class. Explain why pi. Didi was talking about all the things that you get from mathematics. Hope, resilience, and all those type of things. I mean, if pi is the center of mathematics, you get all those type of things. But let's make sure the things we are doing that involves pi is supporting mathematical thinking conceptually. And we'll be fine. Thank you.
Thank you. Thank you very much, Professor Wilmot, for such insightful delivery, touching on the conceptual knowledge in pi, as well as pedagogically, how we as a teachers can support our students to learn the concept of pi meaningfully. The next on our activity is going to be the Pi Day competition quiz. In fact, we have received number of schools indicating their willingness to participate in the quiz competition. This is our maiden activity. It's the first time that we are celebrating the International Day of Mathematics in University of Cape Coast. So our thinking is so small. We want to test how the whole thing will go, so that it can be a festival every year in the Department of Mathematics and ICT Education. So this quiz we only considered our students, level 100 up to our graduate students. Next year, when God permit, we will expand the scope, because by that time we have gotten to know what actually we can do, so that we can even do level-based quiz, primary level, GHS level, SHS level. So, pardon us that our initial thinking, we didn't expand it to cover all the levels, but our graduates and also our postgraduate students. Next year, we are going to expand the scope to include you. So, once they are setting the platform for the quiz, okay, the competitors are going to be on the podium, then the rest of us will sit where we are. And whilst we are getting the place organized, our pie rappers, what are they? Can we get some of them on the podium to give us an interlude? Yeah. Okay. So, yeah, entertain us.
All right, so at this juncture, I think we can use mathematics for fun. So what I'm coming to do is, we are coming to have fun in mathematics, right? All right, so every year or from basic school, they don't teach us the beauty of mathematics. We are always have the ugly side of what? Mathematics. So, right? So if you take 11, for example, you can multiply any digits by 11 without using a calculator or pen or a paper. Can you bear with me? So let's do this one. Let's multiply any digits by 11. So let's say 24 times 11. So the answer will be 264. Then you are done. Are you okay? So let's try this one. 31 times 11 is what? 31 times 11. 31 times 11. 341. Right? You see the beauty of what? Mathematics. And let's do this one. We are coming to square any digit that ends with 5. Right? So 5 square is what? 35 square is what? That's the problem. So you are now come to square any digit that ends with 5. So any digit that ends with 5, we first take the first number. So 25 square. You take the first digit, which is what? 2. After 2, what number? 3. So 3 times 2 is what? 6. Then you add 25. Do you get me? Let's go again. So I said 25 squared, right? After 2, what number comes next? 3. Then you multiply the 2 by 3. Then you get what? 6. So you add 25 to your result. So 25 squared is what? 625. 45 squared. Let's go. What number comes before 4? 5, right? So 5 times 4 is what? 20, then you add your what? 25. So it's what? 20, 25. Are you okay? Are you okay? Let's go. Let's go this one. 65 squared. 65 squared. What number comes after 6? 6, 7. 6 times 7 is what? 6 times 7 is what? 42. So 65 squared is what? 4,225. Are you okay? Are you okay? All right, so I'm coming to do something here. When I get to you, you give me your date of birth. Just give me your date of birth. I'll show you the day you were born using mathematics. A. Okay, let's start from here. Can you please tell us your date of birth?
17 January 2009.
Date of birth, come there.
26 December 2008.
So, based on their date of birth, we can deduce the day in which they were born. So what you are coming to do is, it will take much of time, right? But I want you all to learn something in what? Mathematics. So for the date of birth, if you want to know the day in which the person was born, we call something the magic of what? 9. There's nobody here. I could have showed you how you can deduce the day of the week for every date of birth, right? Are you okay? Are you okay? So let's do this one. We are going to multiply anything that ends with 1. So who can give me any 2 digits that ends with 1? 21 and what? 41. 31. So 21 times what? 31 is 651. Are you okay? Are you okay? Are you okay? So I'm going to show you how you can multiply any 2 digits that ends with 1. So you said 21 times what? 31, right? So you first multiply the leading numbers. So you first multiply what? The leading numbers, which is what? 2 times what? 3. Then to give what? 6. Then you add the leading numbers. 2 plus 3 is what? So it will be 651. Are you okay?
Right. Yeah, at this point, shall we invite our quiz team? Emmanuel and your colleague, can you please come? Yeah, let's give them a hand of applause. Okay. So you take it up from this point. from the university practice, GHS 3. It looks so beautiful, isn't it? Yeah. Happy Pi Day, 3.14, March 14. Shall we give him a big hand of applause for developing such a wonderful artifact? And as I said earlier, next year it will be better than this. We organize it very well to include you. We will really plan for you next year. So whatever you have started learning, please don't go and abandon it. Go and improve upon it. Is that student here? The student who developed this? Oh, he's not here. Okay. So next year, I'm thinking a lot aloud, but it's going to be possible if we get all the needed resources. Probably the quiz competition, we can do it level-based, primary level, GHS level, secondary level. And probably also spread the activities over 2 or 3 days. Yeah. This year, where the Pi Day is not helping everybody, especially our students on campus. They are writing exams. And we appreciate those that they have committed their time to be here. So going forward, we are going to think about it very well and see the best way that we can have this festival. Our primary students, are they ready? Where are they? Yeah, please come. Yeah, let's give them. We like their boldness. We like their boldness. Please come. Yeah, come. Can
Class 6, Ribery.
Classes. Wow. Let's give it to him. Then, please come. What's your name, please? Great. Right. So please sit down and feel relaxed. This is a fun. So the GHS, I learned some competitors are coming. Okay. Let's give them a hand of applause as they come, please. Right. Let's use. Are you all from the same school? And then give us maximum 2. 2 should do. Because we are constrained with resources now. Can we please push the projector far from them? All right. But in fact, I think there's one more chair that we can place behind them. Yeah, come. Yeah, sit behind you. Yeah, so that you can fully participate. We need one more chair for the other one. Okay. All right. Awesome. We are so happy for your boldness and also your confidence. Shall we clap for them? And I believe that you are going to use this one as a test case against next year. We shall plan a very big award on that come next year when we do at the school level. And it will be mega. Right. So our senior high schools, don't worry. Next year, we will do it very big for you guys, okay? At this point, shall we invite the quiz master to come and take over?
Good afternoon, everyone. My name is Edufo Emmanuel, a teaching assistant at the Department of Math and ICT Education. And this afternoon, I'm going to be your quiz master. I'm going to do this alongside Mr. Benjamin Donko, serving as our quiz scorer, Mr. Emmanuel Kodia, serving as our timekeeper, and Mr. Ennis also is going to assist Mr. Benjamin with Dr. Isaac Benning and Augustine Enchi serving as our consultant. I must say that the competition we planned doing it among level 100, 200, 300, and then our postgraduate students. But we have a basic school student and then GHS student. It is going to make it very interesting. If you lose, you lose. But I would say that we expect our postgraduate students to do their best. May the best team win. Thank you.
Committee chair. I just made an observation. Realized that levels 100 to 300, their selection actually does not include a female, and that is serious. You cannot come and do such thing or undertake an activity like this and you leave your female out. So please, why didn't you come with your females and you have come to represent your level alone? Because there are a lot of females in your class. I want to hear you because it's important. Oh, the female will come in as a substitution. Interesting. Level 100, what happened? They were not ready to participate? I don't think so. No. So, quiz master, those who actually didn't come with females, we have to deduct some marks. I'm very particular. I'm particular about gender issues. Yes. Because we have females in the class. See my St. Michael's girls, very brilliant girls. And you are going to do a quiz and there is no female in there. Why didn't you come with a female? Masters. Why? I know they are around, but why don't you have a female amongst you? They cannot be scared. Okay, so Quizmaster, thank you very much. Where is Quizmaster?
Ladies and gentlemen, welcome to the most irrational celebration of the day. Today is 13th March. Today is 14th March, and it's the Pi Day celebration. Today, we honor the most used number in mathematics, a number that never ends, never repeats. We are going to test your knowledge to see whether you are well prepared as to you just use the pi or you understand the importance of it in our daily lives. I am Emmanuel Edofo once again. I'm going to be your quiz master for today. Before we start, we are going to introduce our contestants. Starting from University Junior High School. University JHS is represented by...
I'm in the person of Catherine Devota Penemensa in BS 8.
Please, I am Kwadro Ananarusu. I am in BS 7.
You can do better for them. Our 100 level is represented by...
My name is Queensley Area in Ketiaba Baden, and I'm representing junior high school.
Okay.
I'm Efan Profesiama and I'm in BS 8.
You can do it better for them. Our level 100 student is represented by...
Osei Aldous Fremont and MacArthur William.
Put your hands together for them. Level 200 is represented by...
Clement Mabefa.
Gabriel Donko.
University Basic School is represented by...
Abena Suda is your donko.
Abeno Hene Bachebi.
You can do it better for them. Level 300 is represented by...
Bodu Emmanuel. And Nate Gideon.
Postgraduate student is represented by...
Pascal Henyo. And we are here to enjoy ourselves, so we will allow our genius to have their day.
And Derek Osei.
Let's put our hands together for them. The whole composition is going to be in 4 rounds. Round 1, you're going to test your knowledge on the fundamentals and then history of pi. Round 2 is going to be the true or false. Round 3, you're going to have our riddles. And then round 4 is going to be our recitation. Beginning with round 1, if you answer your major question correctly, you get 3 points. If you're unable to do that, it becomes a bonus to the other contestants. If they answer it correctly, they get 1 point. We are about to begin, and may the best team win. Thank you. For this round, if you are presented with your major question, you have within 10 seconds to present your answer. You have 10 seconds to present your answer. We are starting with our contestant from University Junior High. University GHS, your major question. What mathematical constant is represented by the Greek letter pi?
Please, it is about the Greek letter, the Greek letter pi from the word periphery. 22 over 7.
Sorry, your time is up. Bonus to other competing levels. Please. Okay. If please, if a question becomes a bonus and you think you know the answer, just put up your hand. We'll call you to answer. And for that bonus question, you have within 5 seconds to present your answer. And the bonus question will be given to the level that raises up the hand first. Level 100. Okay. Because some of the instructions were not clear, we are starting all over again. Your question again. What mathematical definition is represented by the Greek letter pi?
22, the ratio of the diameter and circumference, and the circumference to the diameter of a circle or a
Level 100, your question. Why is March 14 chosen as Pi Day?
It is chosen as Pi Day because pi is 3.14, which 3 stands for the March and then 14 stands for the day.
Correct for 3 points. Level 200, your major question. What type of number is pi?
Pi is an irrational number.
Please, please. Please, please.
So the circumference is given by 2 multiplied by pi multiplied by the radius.
Correct for 3 points. Postgraduate students, your major question. What does it mean when we say pi is an irrational number?
It means it can be represented in the form a on b, where b is not equal to 0. That means it cannot be represented as a fraction with numerator and denominator, where the denominator is not equal to 0. It cannot be represented in the form a on b, where b is not equal to 0. Meaning it can be represented as a fraction where the denominator is not equal to 0.
2. 2 out of 3.
Then the correct answer. We want the correct answer.
Okay. So, per the answer provided by the consultant, X decimal expansion never ends and never repeats. That is why you had 2 out of 3. Thank you.
We are protesting the answer. It's the same thing.
University GHS, your major question. In geometry, pi represents the ratio of what 2 quantities of a circle?
Pi represents the circumference to the diameter of circle.
Correct, for 3 points. Level 100, your major question. What mathematical branch mainly studies shapes where pi frequently appears?
Geometry.
Your time was up. Bonus. Level 300. Geometry is correct for 1 point. Time was up, please. Time was up, please. 10 seconds. Hello, hello, hello. Please. The time was up, but the issue is okay. From our chief consultant, because we didn't notify that the time was up, we'll give it to our 100 students for 3 points. Level 200, your major question. Level 200, your major question. What mathematical term describes a number like pi, whose decimal representation never repeats and never ends?
Irrational. Pi as an irrational.
Incorrect. Level 300.
Non-terminating.
Incorrect. Postgraduate. Incorrect. Level 100.
Like it's an infinite series. It's an infinite series. Like 4 multiplying 1 minus 1 over 3 plus 1 over 5 minus 1 over
I'm
5.
sorry. Please, the correct answer is irrational number. Irrational and irrational number are not the same. He said irrational. He didn't add the number. Hello. Calm down, calm down. Hello. Okay. Please, if you talk of irrational is a common language. But if you, he said, Please.
I said pi as an irrational number.
You said irrational. Please. You said irrational. Thank you. University Basic School, your major question. What is the formula for the area of the base of a cylinder using pi?
Circumstance divided by the diameter.
Incorrect.
Pi r squared.
So
Postgraduate student.
the area of a base is
Postgraduate. Postgraduate. Yes. So his hand was up.
Pi r squared.
So the area is equal to pi r squared. Correct for 1 point. Level 300, your major question. Which ancient mathematician is credited with the first systematic calculation of pi using polygons?
Archimedes.
Correct for 3 points. Postgraduate students, your major question. Which ancient civilization approximated pi as about 25/8 around 1900 BCE?
The Babylonians.
The Babylonians is correct. University JHS, your major question. Which famous scientist was born on March 14th, the same day Pi Day is celebrated?
Isaac Newton.
Sorry, incorrect. Bonus to level 300. Level 300. Yes. Albert Einstein is correct for 1 point. Level 100, your major question. Who first introduced the symbol pi to represent this constant in mathematics?
William Jones. William Jones.
William Jones is correct. Please, unless the response is ruled out before you can put up your hand. Thank you. Level 200, your major question. Which Asian civilization is known to have used the approximation? The approximation 3.142.
The Egyptians.
The Egyptians is correct. University Basic School, your major question. Who proved that pi is an irrational number? Postgraduate.
Lambert.
Lambert is correct.
Lambert is not a full name. Lambert is not a full name.
Let us respect them. They are discretion. Otherwise, it will make
University Junior High. Level 300, your major question. Which mathematician proved in 1761 that pi is an irrational number?
Ferdinand von Lindemann.
Incorrect.
Johann Lambert.
That's correct for 1 point. 1761. Postgraduate students, this is your major question. Which famous mathematician later popularized the use of the symbol pi in mathematics?
Lindolphin.
Correct.
Leonard Euler.
Euler is correct. The last set of questions for round 1. And this is a preamble to all competing levels. Name one real-life object whose shape involves pi. Name one real-life object whose shape involves pi.
The top of a bass drum.
The top of a bass drum is correct.
Ball.
The ball is correct.
The circumference of a circle.
Onion. Onion is correct.
A plate.
A plate is correct.
An orange.
An orange is correct.
Polytank.
A polytank is correct. Thank you all. This brings us to the end of round 1.